Hello students. In the last class we were discussing about number systems, chapter 1 number systems. We defined the different kinds of numbers we are having: natural numbers, whole numbers, integers, rational numbers, irrational numbers, and we defined other irrational numbers. And we solved some examples and exercises for rational numbers also, how to represent them in rational form. All these things we had discussed. In today's class, let us learn about irrational numbers. Okay. Before entering into irrational numbers, I will just take out the summary of rational numbers. Okay. Rational numbers. Rational numbers. Right? We define rational numbers as those numbers which can be written in the form of P by Q. Right? P by Q. If any number can be written in this form P by Q, then such a number will be called as rational number. But we have to take one point in our mind that this Q will never be equal to 0. Okay, if Q is equal to 0, we will get a number in the form of P by 0. This particular fraction is not defined. You cannot divide any number by 0. We don't know the value of any number divided by 0. Okay, therefore we cannot write any number in this form. If you write any number in this form, like P by 0, then we don't know the value of that particular fraction. Therefore, when we write the number in the form of P by Q, this Q should never be equal to 0. Okay, should never be equal to 0. When you write in this format, then that particular number can be called as the rational number. Now, after defining rational number, we will obviously define what is irrational number. What is irrational number? Today, I am going to define what is irrational number. Okay, irrational numbers. Irrational numbers are those numbers which cannot be represented in the form of P by Q. Okay, numbers which cannot be represented in the form of P by Q. Okay, but again Q not equal to 0. Okay, you cannot, if any number cannot be represented in this form, then such numbers are called irrational numbers. While talking about the number line in the last class, I told you to pick up all the rational numbers, there will be some more numbers left out, right? In the last class, I was discussing about the number line. We just picked up the natural numbers first, and then we picked up 0 and added to the natural numbers, so it became whole number set. Then we picked up negative integers. So negative numbers also, negative numbers also was picked up, so that when you added that to the whole numbers, it became integers. And then we picked up the numbers which can be written in the form of P by Q, so the set became the irrational numbers. And now I'm talking about those numbers which cannot be represented in the form of P by Q. So the remaining numbers were all picked up, and those numbers which cannot be represented in the form of P by Q will form up the irrational number system. Irrational numbers. Okay. So now, after picking up this irrational numbers, almost all the numbers are picked up. There is no other number left. Therefore, these rational and irrational numbers together form the number line, real number line. Okay. So now I am going to tell you another concept called real number. Okay, real number. What is this real number? Real number is the combination of both rational and irrational numbers. If you join both irrational and irrational number, then it becomes a real number. Okay, real number set is the combination of both rational and irrational number. Okay, so all rational and irrational numbers are real numbers. Understood? Yeah, this is about real numbers. Real numbers form by combining rational plus irrational. Okay, so this is the real number. Understood? Yeah. Now, what are the examples for irrational numbers? Examples for irrational numbers are root 2, then root 3, then pi. So these are a few examples of irrational numbers. Root 2, root 3, and pi. These are few examples of irrational numbers. Okay. Yeah. With this knowledge, let me just check few questions asked to you in your textbook. In your textbook, there is a question asked to you in your example problems. Now, in your exercise 1.2. Now let me discuss about exercise 1.2. Exercise 1.2, there are a few questions. State whether the following statements are true or false and justify your answer. Okay. The first problem is every irrational number is a real number. Is every irrational number a real number? The answer will be obviously every irrational number is not a real number. Sorry. Every irrational number is a real number. So the answer is yes, because real numbers are formed by adding both rational and irrational numbers. So your answer is irrational numbers. All irrational numbers belong to real numbers. Are real numbers. Okay? Yeah. Then every point on the number line is of the form root 10, where m is a natural number. So the next question is every point on the number line is of the form root m. Every point on the number line is of the form of root 10, where m is a natural number. Is this correct? Is this answer correct? Is the statement correct? Is every point on the number line of the form root 10 where m is a natural number? Yes, because the answer is yes, and the reason is the root of any natural number is plus or minus. Okay, root m can be rational or irrational. Even if it is irrational, then you will have negative values also. Root can have both positive and negative values, and root m can have both rational and irrational numbers. So the whole number line is a combination of rational and irrational numbers. Therefore, the answer is yes. Okay. Then the third question is every real number is an irrational number. Is it true? Is every real number a rational number? No, the answer is no, because real numbers are made up of both rational and irrational. So every real number cannot be an irrational number. Some real numbers are also rational. Okay, so the answer for third question is no, because give any one example. Because integer 2 is rational. Okay, you can give any one example which proves that it is not an irrational number. Whichever any one example so that the statement will become false. Okay, these are the questions asked in your exercise 1.2 first question. Okay, and now in order to move on to the further questions, instructions. So it is better to talk about this in the class. So I'll be skipping this exercise and I'll be discussing about this exercise in the classes. So now let us move on to the next part of the chapter. The next part of the chapter is we will surely rational and irrational numbers in decimal form. Okay, now first I will be talking about rational numbers. I'll come to irrational later. Now I'll be talking about rational numbers in today's class. In today's class, let us talk about rational numbers and I'll just give you something about the irrational numbers. Now, I will take a few examples. That is, what are the rational numbers? Rational numbers are the numbers which can be written in the form of p by q, right? P by q, which can be written in the form of p by q, where q is not equal to 0, right? Now today we are going to talk about only rational numbers and talk about irrational numbers in the later classes, but just give introduction. Now I am talking about irrational numbers, okay? Rational numbers. So what are rational numbers? Rational numbers are those numbers which can be written in the form of p by q, where q is not equal to 0, right? So now let's consider three rational numbers, that is 10 by 3, 10 by 3, then 7 by 8 and 1 by 7 according to your textbook. 7 by 8 and 1 by 7. Okay, these are the three rational numbers I am going to choose. Now, how to represent them in decimal form? We will just divide them. Okay, so what is this 10 by 3? Now, if I divide 10 divided by 3, 3 here 10 is the dividend, 3 is the divisor, right? So, I am writing 10 divided by 3. 3 3s are 9, then 10 minus 9 is 1. So now there is a remainder here, therefore you cannot write it as, we cannot write this as, we cannot divide it further. So what we do, we keep a decimal point and then put a 0 here. Again you get 3, so again 3 3s are 9, again I got 1. So now once the decimal point is put, I can directly write 0. So this continues 3.33, right? 9. So it keeps on continuing. So 10 by 3 is equal to 10 by 3 is equal to 3.33 and it continues. Okay, now I'm considering 7 by 8. 7 by 8. What I will do? I will just divide 7. Divided is 7. 8 is the divisor. So now here 7 is smaller than 8. So you cannot divide 7 by 8. Therefore, what do? We will just put a point here. First write 0. 7 zeros are 0. And then put a point. So I get a 0 here. Right? So in the 8th table, 7 by 8. In 8th table, how to divide this? So now I know 7. One second. Yeah. Now I know. Now in order to divide this, 70 by 80. What did I do? It was just 7. I put a point and put a 0. Therefore now I have to divide this. Now 8, 70 by 8. Now I have 8 8s are 64. Okay. Yeah, I got this. Now the remainder is 56. Then the remainder, if I subtract this, I get 4. So 8 5s are 40. So the remainder is 0. Here we didn't get the remainder 0, but here we got the remainder 0. This keeps on continuing, but here it really stops. 0.875. Okay. Now let me consider another example. 1 by 7. Okay. 1 by 7. How to divide this 1 divided by 7? Now 1 divided by 7 is, now again 1 is smaller than 7. So what do? I will put as a point 0 first and then keep a point. So I get a 0 here. 10 divided by 7. 7 ones is 7. So 3. Remainder is 3. So again I cannot divide 3 by 7. So I will carry a 0 here. Okay. Since I put a point here already, I can write any number of zeros. So now I am written here. Then 7 3s are 7 4s are 28. There is a remainder 2, right? Now again 2 is smaller than 7, so I will just write down 0 here. Then 7 2s is 14, and then it goes on continuing. The remainder is 6. Put a 0. 7 8s are 56, and then you get 40. Again put a 0. 5s are 35, and the remainder is 5 again. So here there is no remainder again. I am not getting a remainder. I will just write this. Okay, I am writing this. So 1 by 7 is equal to 0.14285. 1 by 7 is 0.14285. Yeah, see. What am I going to see? See, in these 3 examples, if I just observe, here the number is not terminating, the decimal number is not terminating, it is continuing. Okay, there is no remainder here. You cannot get a remainder, it keeps on continuing. Here, the number is terminating after a particular decimal places. Okay, and here the number is not terminating. Here also there is no 0, it is not terminating, it is just continuing. Okay, yeah, now check. Here, the number is repeating. See here, in the decimal format, in this decimal format, here the number 3 is repeating. Okay, here the number is terminating and there is no repeating. Here the number is not terminating and this number is not repeating also. Not terminating, not repeating. Understood? Yeah. Now, so I will write the condition here. Here in this number, the number is not terminating, not terminating. I'll use other color. Here it is non-terminating, but it is repeating. Okay? Here it is terminating, but not repeating. It is terminating and it is not repeating. So terminating is just enough. But here it is non-terminating, and non-repeating. Okay? So, in this example, here this is non-terminating but repeating. So, it can be called as recurring also. This repeating can be called as recurring also. Reoccurring. Repeating can be also called as recurring. This can also be called as non-recurring. Okay? Yeah. So in this example, non-terminating and repeating. Here it is terminating and here it is non-terminating and non-repeating. Okay. So now these two categories in which the decimal form of the fraction p by q is non-terminating and repeating or terminating belong to rational numbers. This belongs to, I erase the upper thing. This belongs to rational. Okay. The concept, the numbers whose fraction value is both non-terminating and non-repeating will belong to irrational numbers. So this is how we classify rational and irrational. Understood? Those numbers whose fractional values is non-terminating and recurring or just terminating, then they belong to rational numbers. Those numbers, fractional numbers whose value is both non-terminating and non-repeating belong to irrational numbers. I hope this is clear to you. Now, how to represent these numbers? Now, how to represent these numbers? See, in this number, irrational number, even if you have written it, yeah, and come back to this, even if you have written it in the form of P by Q, I am telling you this particular concept belongs to the irrational number. I will answer this question in the next class when I am talking to you. Okay, so though this is non-terminating and non-repeating, it can be written in the form of P by Q, therefore it is a rational number. I will talk to you about this irrational number in the next class and tell how this number became a rational number. Okay. Yeah. Now my point of view is just now my point of view is just rational numbers. Now I'm not talking about the irrational numbers. I'm talking only about the rational numbers, where rational numbers you have like this. Okay, in case one you have this. So in order to represent this recurring numbers, you can just write 3.3 dash. If you write a dash on this means that this particular number 3 keeps on repeating n number of times. Okay, this particular number 3 keeps on repeating n number of times. Understood? So if you write just dash over the number, it becomes like this. Now, if I may have many other examples like 1 by 2.7. Okay, this 1 by 1.27, like this, it keeps on recurring and it goes on. So I can write that as 1 by 27 to the power. I can just write the back, not to the power 27. That means that this 27 keeps on repeating. If I have 3 digits recurring, 3.357, 357, 357, if this keeps on repeating, then I can write it as 3.357 bar. Okay, if there are 4, whichever factor is repeating n number of times, then that can be written in this bar. Whatever value write in this bar will represent the that particular number is repeating n number of times. Understood? Yeah. So this is about rational numbers and representation of rational numbers in the form of decimal format. Okay. Exercise 1.3. Exercise 1. Write the following in decimal form and say what kind of decimal. Question is 36 by 100. Okay. Now you have to write this 36 by 100 in decimal form and tell what kind of decimal expansion it is. Like, is it terminating or non-terminating and recurring? You have to tell that. Okay. So now, in order to do that, we should just divide. Right? So 36 divided by 100. Right? 36 divided by 100. Now I cannot divide this 36 by 100, so I put a 0 and then point. Okay. Now 100 threes is 300 and 60 is the remainder. So if I put, there is a point already, so I can directly write it as 0. Write a 0 here, and 600 is 600. So the remainder is 0. Since the remainder is 0, see the remainder is 0, so the decimal expansion ends here. Therefore, this particular decimal expansion is terminating decimal expansion. So the decimal form of expansion is 0.36 and it is a terminating expansion. It is terminating decimal expansion. Okay, so this is what understood. So now the next one is the second question is 1 by 11. Next question is 1 divided by 11. Let me solve this 1 by 11. 1 and then put a point and put a 0 here. Since I put point here, I can write 0 here. Now again I cannot divide 10 by 11. So I can put another 0 here and write 0 here. Now see what I did. I cannot divide 1 by 11. So what I did, I wrote a 0 here and then put a point. Since I took a point here, I wrote 1 0. Again, 10 is not divisible by 11. So I write one more 0 and write 0 here also. So 11 into 0. Now I got 100. Now I have to divide 100 by 11. So 111 nines is 99. So again I get 0. Again it goes on repeating. Now I put 1 cannot be divided by 11 again. So I write this 0. Again 10 cannot be divided by 11. So I write 0 again. I erase this. I explain you how I wrote this. 11 divided by 1 was 0. It cannot be divided, so I put 0. Again 0. So I got 9s are 99. So 1 is the remainder again. So again, because of this point, I can write 1 0. I wrote 1 0. Now after writing 1 0, I cannot divide 10 by 11. So I put another 0 here and I get 100. This becomes 9 and this keeps on repeating. Therefore, the value of 1 by 11 is 0.090909 and goes on. So here you have to observe that this particular 09 is repeating, that is, it is recurring. So I can write this as 0.09 bar. Okay, so this decimal expansion is non-terminating but recurring. Okay, so this particular decimal expansion is non-terminating but recurring. Understood? So the previous problem it was terminating. In this problem it is not terminating but recurring. Now let us solve the next problem also. The next problem is 4 I hope you know how to solve this mixed fraction. In order to solve this mixed fraction, you should first multiply this number, that is 8 into 4 is, what is 8 4s are? 32. 8 fours are 32 plus after multiplying this you will be adding 1. So plus 1 by 8. This is how. So in order to solve this mixed fraction, you will first multiply 8 into 4 plus 1 divided by 8. This is how you will be solving this mixed fraction. This is how you will be converting mixed fraction into proper fraction. Now we have to simplify this. 8 fours are 32. 32 plus 1 by 8. 32 plus 1 is 35 by 8. Okay, this is 35 by 8. Okay, this is the fraction you have to solve now. Now, let me find out the value of 35 by 8 as 33. I'm sorry, 33. So 33 by 8. Now 8 fours are 32. Remainder is 1. I put point there. Okay. If I put a point, I can take a 0 here. Now 8 ones are 8. 2 is the remainder. Okay. This is 8 twos are 16. Now the remainder is 4. So now 8 fives are, now there is a point, 4 is not divisible by 8, so I will write a 0 here. Now 8 fives are 40. Therefore the remainder is 0. That means the value of 33 by 8 is 4.125. So how is it? It is terminating decimal expansion. Okay, this is terminating decimal expansion. Okay, and terminating and non-recurring. There is no number which is recurring. Okay, therefore this is a terminating decimal expansion which is non-recurring. Understood? You can write terminating decimal expansion. Okay, so this is about the third problem. Now let me solve the fourth problem for you. Solution for fourth problem. Fourth problem is 3 by 13. 3 by 13. Yeah. Now 3 by 13 I should directly solve. So I will be dividing 3 divided by 13. So 3 is smaller than 13, so it is not divisible by 13. So I directly put the point, 0 point. Now I take 0 here. We know 13 twos are 26. Then 4 is the remainder. Okay, 4 is the remainder. Now again, since there is a point here, I can directly write as 0. Now I know 13 threes are 39. And now there is a point here. There is a remainder here 1. Now since there is a point, I can directly write 1 0 here. Now 10 is smaller than 13. Therefore, I will write zeros on both sides. I write a 0 here and take a 0 here. Now 13 divided by 100. Now we know 13 so this continues. So 1 second. Yeah, to solve this 13 zeros are, I'm repeating, 13 twos are 26, 4 is the remainder. So I put a 0 here, then 13 threes 3s are 39. Now I took one, there is a remainder here. Now I put a 0 here just because of the point since 1 is not divisible by 3. So now what did I do? After taking 0 here, now 91. 13 sevens are 91 and there is 9 here. Remainder is 9. Remainder is 9. So after remainder, I got 9. I get 13. I put a 0 here because it is already a point. And I know 13 6 is 6 3s are 18 and 6 1s are 6 plus 1 78. So the remainder is 12 again. It goes on. So now I take 0 here 120. I know 13 9s are what is 13 9s are is 117. So it becomes procedure will be following again. Okay. If you want I show. So now I got remainder 30. So once I got the remainder as 30, it will start again. Now 13 ones are 13. Remainder is 30. 13 ones are 30. So 13 twos are 26. Again 4 is the remainder. Since 4 is the remainder, again I take 0. So you get 13 threes are 39. And the same thing. So this particular value 230769 keeps on repeating. So this becomes 230769 is recurring. Okay. Therefore, the value of 13 by 3 by 13 is 0.230769 and it recurring and it is a non-terminating. So this fraction is non-terminating and recurring. Okay, so this is non-terminating and recurring. Therefore, this particular, see here, how many numbers digits are recurring? 6 digits are recurring. Therefore, this fraction is a non-terminating and recurring numbers can be any number. Here there are 6 digits that are recurring. You can have up to 9 digits recurring, up to 9 recurring digits. Okay, so this is the value of 3 by 30 and this is a non-terminating and recurring fraction. Okay, now I give an assignment to you. Exercise 1.3. I'm writing assignment here. In this assignment, first and 6. Okay. Exercise 1.3, first main, 5th and 6th is your assignment. Okay, I'll give you a question also. I'll give you the question also. Your assignment question is, 5th question is 2 by 11 and 6th question is 329 by 400. Okay. So these two are your assignment questions. Please solve the assignment so that in the next class you can follow up easily. Okay. So please solve the assignment. Hope you have solved the earlier assignment also. While providing the notes for today's class, I will be giving you the solution of previous assignment also. Understood? I hope you remember and you have solved the assignment. There was an assignment in exercise 1.1 to find 6 rational numbers between 2 and 3. Right? You had to solve that question. If you have solved it, it is well and good. I will be passing on the solution for that question in today's notes. And today's assignment is these two problems. I hope you have understood how to represent a rational number. Whatever representation I gave in decimal forms, they are all decimal representation of rational numbers in decimal forms. Okay, whatever I told you until now, the recurring decimal form, non-terminating decimal form, they are all the decimal representation of rational numbers in decimal formats. Okay, in the next class, let us discuss about converting this decimal formats into rational numbers, that is P by Q format. Okay, after that, we will go on to the irrational numbers. So, in today's class, we learned about how to represent rational numbers in decimal format. Okay, so this is the end of your class. Let me wind up the class by reminding you about the two assignments. Okay, these two questions are your assignment. Please solve the assignment and mention. Okay, I'll write a question also. Write the following in. Write the following in decimal form and say what kind of decimal expansion it is, and say what kind of decimal expansion is it. Okay, this is your question. If you have already purchased your books from the school, you can easily access to this question. So you have to write these two numbers in decimal form and then say what kind of decimal expansion is it. Like, is it terminating or is it non-terminating recurring decimal fraction? Understood? So this is what you have to solve as an assignment, and today you have learned about representing rational numbers in the form of decimal forms. So this is it for today's class. Let's meet in the next class. Thank you.